it and how when to make copies?
Did you know that sloths are so slow, sometimes they grab their own arms thinking they're tree branches and it kills them?
What was that?
I said sloths are so dumb that sometimes they grab their own arms thinking they're tree branches and they fall out of a tree and die.
Why is your volume up to 200?
That was actually low for him.
That was.
It's loud for me.
Hey, thank you.
Holy
sir. I appreciate
it's
that.
not loud for you. I've heard you.
This morning it is, 'cause it's in my ear.
You look so pretty this morning.
Stop lying. Miss Taylor!
You should have, this is not.
You did?
So you should have it.
Every time somebody says
This
something.
is an example of factoring. We have to start, this is the problem with factoring. You can't separate it all too much in your head, if that makes sense. Like, you have to look at it, and it can be any one of those, every time. But the problem is the way we teach it is, we teach you this kind, and then this kind, and then this kind, and you start to say, well, which kind is it? And that's the hard part. The actual factoring isn't the difficult part. It's the figuring out which rule you're supposed to use. So, we have to learn to look at them and just say, we're just going to do what we can. So first thing we always do is see if there's a GCF. Is there anything in common that we can take out of here?
2.
3. No, 2.
Within my backpack? No.
18 divided by 2,
I
that
got
leaves
this.
9 in here. And 8 divided by 2, that leaves 4 in here. Now, we've only learned one strategy so far.
The difference of squares.
But what you would do is you look in your little chart, there's 2 terms here. So, which of them could it be? We've only learned the one, but again, you would look through your list, and this is a difference of 2 things that are perfect squares. So to do it, we need 2 sets of parentheses. That's pretty much what always happens in factoring, 2 sets of parentheses. One gets a plus and one gets a minus. Right here goes 3x. Why 3x?
Because it's 9.
Because it's the square root of 9x squared. The square root of 9 is 3. The square root of x squared is x. And then over here goes not 2, not 4, 2. All right. They caught it? Then, just for good measure, this is at the bottom of the chart, we have to make sure that none of it can be factored any farther. So this is clearly not a difference of squares because there's plus in there. And this is not either because 3 and 2 aren't perfect squares. They have a square root, but that square root is not a whole number. So we're finished with that. So, I have made a decision and I sat here debating now. I debated about it all weekend and thought I would be confident, and then I wasn't, and I really don't. Wait, guys, changing my mind. We're going to do sum and difference of cubes. This is not the order the book does it, but I like to do all the ones with 2 at the same time. For some reason, they did difference of squares and grouping, and then they come back and do sum of cubes. I don't know what they're doing. I don't know who writes it. Not me. You're making a lot more money. So we're going to do sum of cubes and difference of cubes. So first we have to know what they look like. I don't know if I know. Here's the rule, so you probably want to put that on your paper.
What's this called?
Sum of cubes and difference of cubes. What is sum? That part's already written on there. So is this the sum or this is the rule?
Oh, they are.
This was the sum of cubes. This one's the difference of cubes. These are not easy to memorize.
I have to memorize all these.
Yeah.
Is this AB or is it A minus B or?
Thank you. And then that second one, we put in your difference. This is the sum of cubes, and this is the difference of cubes. This rule is kind of easier, I think. You just take the square root of each, and then you know to put the plus in one and the minus in the other. This is a little trickier. Not a lot trickier, but a little. It won't be too bad if we practice it. important that you understand it than that you memorize it. So if you have to choose where to put your energy today, you can always write this rule down and memorize it some other time. So your focus should be on, do I understand what she just did? Because memorizing the rule won't do you any good if you don't know what to do with it when you look at the problem. So I'm going to start with an easy one, like x cubed plus y cubed. Is that a sum of cubes or a difference of cubes? Sum. Does it really matter what you call it? No, as long as you know what to do with it. This is just a rule that tells us how that factors. Keep in mind that factoring means if I multiplied those back out, I would get this. We're trying to figure out when you're factoring, you're asking yourself, what did I multiply to get that? This one is just a rule that you memorize. So here's what we do. We have a little parentheses and a big parentheses, and the signs alternate. On a sum of cubes, we start with a plus, and then minus the plus. And then we just have to figure out what to put in it. We take the cubed root of this, which is x. We take the cubed root of this, which is y. Now I'm done. All right, now we square this thing. Square this thing. And in the middle, we multiply them together. I know that was an easy one. That was just basically a repeat of the rules from the track. A little bit tricky.
Wait, what'd you do in the middle?
I multiplied them together. X times y, x, y. Now let's put a number in it. This is going to be the catch. Do you recognize that that's a perfect cube?
Yes.
It is. But you're going to have to know those when you see them. Luckily, this rule only applies when there's two terms. So if you see two terms, what you're just mentally going to do is, okay, could this be a difference of squares? No, for a lot of reasons. 8's not a perfect square, and this isn't a minus, okay? Could it be a sum of cubes? So you're going to have to mentally ask yourself, which one could it be? So when we look through this one, that's a perfect cube. So with that, so this is a sum of cubes. That means we need to put our parentheses. The signs alternate. I start with a plus, because the problem has a plus in it. Minus. All right, the cubed root of 8 goes right here. What to the third gives you 8?
2.
And the cubed root of m to the third goes here, so that's m. Now square it and put it in the front. What is 2 squared?
4.
All right, and square this and put it in the back. What is m squared?
4 squared.
In the middle, multiply those two numbers together. 2 times m is just 2m. Is it a difference of squares? No. But it is a difference of cubes. Those are both perfect cubes. Our first step should always be, is there anything we can factor out of there? No. What is the cube root of 64? I took that out of the book. 4. Oh, then you can't. It might not be. I took it out of the book. I trusted you. Excellent.
It is 4, isn't it?
4 times 4 is 16. Times 4 is
64.
No.
16 times
It's
4?
64.
Oh, it is? Oh, then it is?
Yeah.
Alright. Your calculator will do a cubed root.
Where?
This is a good time to stop and realize that.
How?
You might have a cubed root button. Some people do. Can I borrow yours so I can write what it looks like? Some people have a cubed root button. This is a square root, right?
Yeah.
Alright, if they have a cubed root button on yours, it looks like this. They just put a 3 there to show they're doing a third root.
They didn't give me
You
that.
may not have a third root button, but in that case, you probably have a button, you might have a button that looks like this. This says whatever root you want. So it'll do third root, fourth root, fifth root, sixth root. And then I just have to figure out how to do it.
You do the little up arrow.
That's when you're squaring the computer.
Mine's just you put the number and then you press the button.
64. They are all different. I'm gonna have to figure some of these out. That's what it does. The question is, how do you make it do it?
You found it on yours?
Yeah, I found it.
Kaylee found it on hers, and we have the same calculator.
But I don't know. They gave me Zebra.
I see the button. I just don't know how to make it work.
You just press 64, and then that button, and then you press 4, and hit equal. Right?
Oh, mine is like you put the number first and then you press second and then.
That's how mine is.
Put the
Yeah,
number.
mine.
So the number you're trying to find the root of.
Okay, put 3 and then do second, the whatever the button is for the cube, like 3 and then
I'll
do
do
the
it.
cube button.
Is that the same calculator as mine?
Okay.
I don't know.
Yeah, it is.
You may have to just experiment, because you're gonna have to enter the 3, but you may have a cubed root button. It's worth taking the time because you may need this again. So I don't. This is not a waste of time. Maybe this is
Press
good.
3, and you go second, and you see that little thing right here? That's it, so you press this.
And then you put 64.
Ah.
That's what mine does.
So the third root of 64. So
Yeah.
that's how you do
You have
it.
to, if it has the X, you have to put the number first of what you want it to be like.
If you have a third root button, you're just gonna be able to push this button and then 64 equals. If you don't, then you have to put 3, then this button to show what you want the X to be. So, and then the number equals. Does anybody not have either of those? Because there's still a way. So everybody's got one of the two, or either does it here? No. Okay. And that's because I want you, if you're not sure if something is a perfect cube, you should be able to check it in your calculator to see if it is. Alright, now, we did that, so we're going to do our 2 sets of parentheses. Anytime we're factoring, it boils down to drawing those 2 sets of parentheses. For difference of squares, we put a plus in one and a minus in the other. For difference of cubes, we have to do 3 signs. We're going to start this time with a minus, and then plus, minus. Alright, and then right here, I'm going to put the cubed root of 64. And then I'm going to put the cubed root of 27. And the cubed root of y to the third.
There's a negative sign or actual thing, how do you do it? Wouldn't it be minus 10? Negative.
Minus, plus, minus.
I know, but like,
It isn't, no, is it?
Negative 27.
The rule is not, it always ends with a plus. I knew that. It always ends with a plus.
Isn't it negative 27, so wouldn't the cube root of that be a
These
negative?
two alternate, but then it always ends with a plus. I knew that.
Sorry, go ahead. So it's like negative 27, so wouldn't the cube root be a negative?
Minus 3y.
But the formula calls for negative, so wouldn't the negatives cancel and it's positive?
No. When you multiply it out, it's longer than that. Like, it's not that. Let me show you later. I'm putting the cubed root of each. Right here, I square that thing. So what is 4 squared? And then right here, I square the other thing. So 9y squared. And then in the middle is where I multiply them together. So 4 times 3 is 12y.
So don't worry about the signs in front of them when you're multiplying, just plug it, just
We're,
put the
we're following
sign.
a formula, and the formula told us what signs go there. Because it's already worked that out for you, if that makes sense. If we were to multiply this back out, we would get, and I think it's worth doing it one time. So let me get some. We should get what we started with. So what we would have to do is 4 times each thing in there. Then negative 3 times each thing in there. Here it is, Sarah. Do you see when we do the negative 3 times each thing in there? Negative 3y times positive 9y to the second will give you negative 27y to the second. So you would do 4 times the 16, that gives you the 64. 4 times 12y, that's plus 8y. 4 times the 9y, that's plus 6y squared. And then the negative 3 times everything. Negative 3 times 16 is negative 48.
Yeah.
Y. Negative 3 times the 12y gives you negative 36, y to the second. Negative 3y times the 9y to the second gives you the minus 27, y to the third. The 48y and the negative 48y cancel. The 36y and the negative 36y to the second cancel. So all that's left is the 64. See, that will always happen. So someone just gave us this formula. Thank God you're not the one that had to come up with the formula yourself. You just had to memorize it and then plug the numbers in because it'll always do that. Yes, ma'am?
On the one, like, right behind you, there's like 4 minus 2 and, why is there a negative in front of 2?
That's because that's what the rule says. It says put a negative right here. Start with a plus because there's a plus in the problem, and the next one would be opposite.
And then why is there a positive minus?
Start with a minus, the next one is the
Oh, so
opposite.
those are different, okay, gotcha.
Okay, now, we've learned 3 of them, and we've learned all of the 3 that are in the what if there are 2 terms section. So, they're not like terms, we can't put them together. Is there a greatest common factor? Always ask yourself that question.
Y to
It is, and what is it?
the, y to the 4th.
Okay, so we have 50 minus y to the 6. Does that meet any of our rules for 2 terms? Is it a difference of squares?
Yeah.
Is 50 a perfect square? What's the square root of 50? Just punch it in a calculator if you're not sure. Because these tests are going to be mentally draining. They're hard. So don't waste all your mental power on stuff you can just type in. Not a perfect square, so this is not difference of squares. Could it be difference of cubes? Is 50 a perfect cube?
No.
No, we're finished. That's the answer, it is factored. That's what's tricky about factoring is knowing when you're finished. Because you have to go as far as you can. And in this case, that's as far as you can go. Sometimes all you can do is take out a greatest common factor. I'm going to start using there. You know, there are none. What's the first thing we should try to do?
Greatest common factor.
Greatest common factor. What is the biggest thing we can take out of that?
X, oh, no, just kidding.
2. So that leaves us 25x to the 6 minus 9 y to the 8. Now we have a difference. So our only options are difference of squares or difference of cubes. It can't be sum because That's not a plus. So, is this a perfect square? Is 25 a perfect square?
Yes.
Yes. Anything with an even exponent is a perfect square. So is 9. And that's an even exponent, so that is a square. Alright, so I'm going to keep the 2, it's just coming along for the ride. We're not doing anything with it, we're just bringing it down with us so we don't lose it. I'm going to write my 2 parentheses, and this is a difference of squares, so I'll put a plus in one and a minus in the other. We don't need 3 signs unless we're doing a difference of cubes. The square root of this, what is the square root of 25x to the 6?
5x to the third.
You are right, 5x to the third. We're just cutting that exponent in half. It goes in both spots. What is the square root of 9y to the 8?
3x to
Now, because this is the rule, we have to make sure that we can't factor again. Sorry. I keep my phone on because I have 2 small children at home. I apologize if it goes home. I'm scared to shut it off in case someone's super down. Alright, so. Hopefully they'll call the fire department first, but. Alright, so let's look at this one and see if it can be factored any farther. Could this be, it's a sum, so our only option is, could this be a sum of cubes? Is 5 a perfect cube? No. So that one's finished. This could be either one of the differences. Is this a perfect cube?
No.
Is it a perfect square?
No.
Then we're finished. I know that seems tedious, but if you have to get in the habit, particularly for something like ACT, of checking each piece and making sure you're finished with it before you move on. So we're finished when we can't use any of our rules. And now I'm going to make sure nobody's standing on that. Say that, we get terrible. Sure they wouldn't text me, right?
Unless there's one in the house.
Not important. I shouldn't. Let me text my husband at work one time, and he will answer back. No matter how important what I asked was, like, did you give the baby his medicine? He'll be like, I am working. You want it? I'm going to be like, that's longer than no.
If you would have 5x in parentheses and the exponent on the outside, would that be a,
Oh, alright, ask me that again.
like 5, like, open parentheses, 5x close parentheses, to the third? It's 5x is the whole thing would be
Alicia, I really love how you're able to pop everything, but it is very distracting.
Oh my
So
gosh,
if
it
you
takes
were
like
really
5
Sorry, what was
seconds.
that?
So would you please?
Because the 5 is off. And in that case, it's not.
It gives you arthritis.
It does not, that's a lie.
These are all lies. There is no empirical proof that it causes arthritis.
It doesn't, because my ankle stays the same.
You're right, there is no proof that it causes
Yeah,
that.
that is-
It's something people say when they wish you would stop making that noise.
A guy when he was 20 started popping every knuckle in his right hand for every day of his life, and then in his left hand he never popped his knuckles, and nothing happened. His hands were exactly the same.
I think it's habit forming, I think that could cause you to, some people do it, some people never do it. Habit, okay. I gotta give you some, I don't want it to be a lot.
But it's a holiday.
I do understand that, so I guess what I'm saying is work fast.
Okay.
I think I lost 20 years of my life.
Wait, is the problem?
Oh, you're-
Oh, these are the problems that you're giving us?
Grades are the problem.
Oh my gosh.
I was like,
We walked out of the stadium.
We almost won. We had it right there, and he freaking missed
3
snap.
Oh, yeah.
I mean,
How do you fumble
Should've lost
3
last
times?
week, too.
missed the,
I
no,
don't know what
he
we're
missed
talking about. I thought we were talking about the basketball game.
Oh,
Are
yeah,
you
all of
kidding
them were
me?
awful.
Hey guys, it was
Shut up.
it was a monumental day.
They were awful. They should have killed him.
Yes, I know it was awful, but no, don't be an Alabama fan like that. That's just
I'm not an Alabama fan.
1 minute.
No,
in the
no.
first
Hey,
quarter, they score.
your thing's all cattywampus.
In the first 2 minutes, we were already down.
biggest
14
gap
nothing.
of my life.
That's terrible.
There we go.
Exactly.
I was so mad.
Awful.
I was
Yeah,
little.
shit happens.
Frat boy comes out and says, I totally,
And like,
I watch it all.
They should have lost last week too. If that guy hadn't fumbled it on the one, they would have lost.
He goes, oh, sorry.
I'm gonna be honest. I was watching Criminal Minds.
I'm gonna be honest, don't tell my husband this, I do not give a rip about Auburn football, but I've now been watching it for 14 years, despite the fact that I do not care. And here's what I've learned about Auburn. No matter how good they are, they will continue to do that junk. That's what they do.
I don't know
When Alabama was trying to overcome America. Auburn University is trying to destroy America.
Yeah, I had the TV up to like 7 because my dad was screaming so loud.
Yeah, I don't really care. I just like to get people mad about it.
I don't even. I
I
didn't even know it was
It really entertains me to watch how upset people will get when you say things like, "Wow, y'all suck."
Yeah. And I don't even care. Oh, the worst.